Good morning. This is Steve Cantrell with DBA Fundamentals first session in April. Today we have Paul Randal doing index fragmentation, internals, analysis, and solutions. But first, I kind of got to go over a few things to pay the bills. This is our sponsor, Century One. We've got a new sponsor coming in shortly, but I haven't had the meeting about that yet. But hopefully we'll get to keep both of them. But anyway, they're a fantastic sponsor. They have some fantastic resources. Here's, if you want to do a little camera at the top of your screen and print key this has got some great links to a lot of great free stuff. If not, just go to century1.com and check out what they have. The Plan Explorer, it's worth going just to pick up Plan Explorer, and it's totally free, so try that out. Virtual group news. Oh, well, let me back up a little bit here. We have our discount codes available, and it'll save you $150 off registration for Past Summit. Every other group has the same thing. Every local group, local user group, and if you want to support support them, and I wholeheartedly want you to do that. But one of the things we do is we put everybody that uses our discount code into a pot, and we give away an extra $500 Amazon gift card to one lucky person. So it gives you a little extra spending money to maybe pay for airplane, a local car, food, something like that. But anyway, look at our code VGDISM843 and utilize that when you're registering. Some of our upcoming sessions will have Thomas LeBlanc with Execution Plans for Beginners, April the 17th, and Kendra Little, Index Design Patterns for Beginners, in the first session in May, and then Jess Borland with SQL Server Agent in June. Some of the other virtual groups that are out there, Saturday Night SQL is a great one. The cloud sessions, thought I had some others in there. Lots of other virtual groups. Check them out and try them out. There's one for just about every language out there. Not every language, but every major language. And every topic. They don't always give sessions monthly. Sometimes they give 3 a month or 4 a month like we do, and sometimes they give one every other month, but they're all good and they're all worthwhile. Go check them out. SQL Saturdays is another form of free education. You can go to SQLSaturday.com and find out if there's one close to you that you can join. It's an event where there's speakers that are learning how to perform the craft of speaking in front of people and teaching others. So you get tons of free education. The only thing you usually have to pay for is your lunch, and that's not a big deal. Sponsors pay for everything else. There's also, it's like a little mini convention, so definitely check that out. Anything within 50 or 100 miles is great to go to. We will be recording this session, and you can get to it from our website at dbafund.org or our YouTube site at dbafundtube.org. Oh, and I forgot to mention, we do have a contest going on through the end of June. Instead of giving stuff away every month, we like to give it away all at once. So all of the funds that we had available were given away at the end of June. If you follow us on YouTube, if you're a member of PASS, and if you follow us on Twitter, you're entered. Every session that you attend between the first of the year and the end of June, or the last session in June, gets you one entry. There'll be 3 people drawn. One person will get $1,000 Amazon gift card. One person will get 300, and one person will get 200. So be sure and make yourself eligible for that. If you're going to be coming to our sessions anyway, it makes sense to go ahead and do it.
That's pretty cool.
Oh yeah, it's a lot easier for us too, since we've got the Australian chapter, and it would just be harder to break everything out. So we kind of, that way it's just the same for everybody. Anyway, let me get with Paul. I actually have taken more time than I meant. I've been trying to cut down my presentation. Everybody pretty well knows Paul Randal. He used to work with Microsoft. Now he and his wife run SQL Skills, and it's some of the best content and education out there.
Your check's in the mail.
I will get you the address later. Anyway, yep. Let me go on and get to him. He's a lot better at this than I am, so hopefully the rest of the session will be better. I'm going to turn it over to you now, Paul. Let me get you. I don't know why I'm like running in first gear this morning. It's just, so I'll get out of the way and let Shane and Paul take over.
All right, you guys see that?
Yes, looks good.
Perfect. All right, thanks, Steve and Shane, for inviting me back. I haven't done one of these for your group for about a year or so, but I always enjoy doing these, hitting a whole bunch of people up. So we're going to talk about index fragmentation, internals, analysis, and solutions today. One of my favorite things, I actually wrote the original DBCC index defrag and DBCC show config for SQL Server 2000, so this is a subject that's near and dear to me. So as Steve said, we're recording, and I'll send Steve a PDF of the slides and a zip file of all my demos, and he can post that up there as well. The way we're going to do questions is I'm going to stop every 5 minutes or so and say to Shane, hey, any questions? And if there's any pertinent questions that he hasn't already answered in chat, then I'll take those. And then at the end of the session, I'll hang around for as long as people have questions as well. So a couple of quick slides about SQL skills. There's 6 of us that work for SQL Skills. You probably recognize a whole bunch of those names. We do training, consulting, we have stuff up on Pluralsight, and so on and so on. We have a bunch of classes coming up in Chicago in April and May, and also in Bellevue in June and London in September. We're not having any fall classes this year in Chicago like we usually do. So if you want to come along to one of our classes in the US, those are your choices. We're also starting to do a bunch of online live classes as well. We just announced a new one yesterday on Query Store that Erin's going to be teaching in May. And we also have one in a couple of weeks that Kimberly's going to be doing around partitioning and very large tables. So if you're interested in those, all the details are there on the slides. And then we also do a bunch of online training recorded through Pluralsight. If you're interested in getting a free trial of that, no catches at all, you don't have to put a credit card in, just a 30-day free trial. Send me an email just saying use a group Pluralsight code, and I'll shoot you back a code, and you get 30 days to watch as many of the 175 hours of content as you absolutely can. And then lastly, the least important thing, a little bit about me. As Steve said, I used to work for Microsoft for almost 9 years. I wrote a whole bunch of the code, I managed the storage engine, and so on and so on and so on. The interesting stuff there on that slide about me, my email address. If you have any questions about this session, either today after you've been watching it, or if you're watching it on YouTube and you want to shoot me a question about something to do with fragmentation, please do. Make sure you put in there a pass virtual group question or something like that, because I get lots of emails every day, and I like to have the questions that people who've seen me speak or heard me speak get answered first. And then my blog, lots of interesting and completely free stuff on our blogs, and we're also all on Twitter as well. So what are we going to talk about today? Index fragmentation. Fragmentation is inescapable, as it says there, because as soon as you start having non-clustered indexes, almost by definition, those non-clustered indexes don't match your insert pattern. And so you've essentially got random inserts. Also, if you have a clustered index that has some kind of random key, like GUID, you're going to start to see fragmentation. Now, fragmentation itself is not the only problem. There's the cause of the fragmentation, and there's various different kinds of fragmentation as well. Now, you've probably seen or heard people, well-known people even, saying you don't have to care about fragmentation anymore. If you have SSDs, you don't care about fragmentation. And that's not true. because what they're meaning by fragmentation is just the slowdown in scans, and that can be mitigated by faster hardware. But there's the cause of fragmentation and all the wasted free space that hardware doesn't help in any way. So I'm going to try to convince you that you do have to still care about fragmentation. You don't have to sledgehammer rebuild everything every night, but you do have to care a bit about fragmentation because it can affect your performance. So we're going to cover 4 things. We're going to cover how SQL Server uses an index, and that's the kind of base information to know why fragmentation can be an issue. We'll talk about the various kinds of fragmentation. We'll talk about how fragmentation happens, which is basically an operation called a page split. And then we'll talk about how you can detect fragmentation, basically using the DMV index physical stats, how you can mitigate fragmentation, basically using a fill factor, and your options for removing fragmentation. And I'll do a few demos as we go along. So first off, this is a basic index structure. And the structure is really the same whether we're talking about a clustered index or a non-clustered index. And I should say that in this session, we're only talking about row-based indexes. We're not talking about column store indexes. So every access to the index starts through the root page. And then depending on what we're doing, it's going to go down to the leaf level and read one row or multiple rows. And I'll talk a little bit about that in the next couple of slides. There are 0 or more what I call intermediate levels. And then there's the leaf level. And if this is a clustered index, the leaf level are data pages, and that is your actual table. These are your table rows. If it's a non-clustered index, these are index pages, and the rows are an awful lot smaller. The problems that we have with fragmentation are the same, whether we're talking about clustered or non-clustered indexes. Now, one more thing to notice here is these arrows going to the right and going to the left, and that's at every level of the B tree. And this is what's called a doubly linked list. The pages are linked together to allow an ascending order scan or a descending order scan. Okay. So the first use of an index is a single record seek. So you've given a search predicate that's going to match one record. The storage engine has to start, and this kind of nothingness up here is the metadata that has the page ID of the root page of the index, the very top of the triangle that we write as an index. It goes to the root page, and based on the records that are in here, and we're not going to get into the depth on the index contents, based on the records that are in here, it can make a choice about which way through the index to navigate. Okay, and this is a very simple contrived case. So let's say it chooses to go down to the left-hand branch, and in this page here, there's enough information for it to decide which of the pages at the leaf level here has our record on it. So it chooses this way, and it finds our record. Okay. Now, there's a link up here. If you're a little bit more advanced and you want to know a little bit more, there's a cost of doing this search, okay, per level. And it's a few microseconds. It's like 50 or 100 microseconds, depending on your processor speed. But there is a cost per level. So it pays to try to keep your index keys small so that the number of pages down here that can be represented up here is as large as possible. That means as many rows as possible can be here, and as many rows as possible can be here. And that means that there doesn't have to be so many levels in the index. And this would be 1, 2, 3 levels. There's a per level cost. And again, if you're a bit more advanced, you want to know some more information, go look at that bit.ly link there. Now, after a single record seek, there's a multi-record seek or a scan. And this is where you've given a starting and ending predicate. And what the storage engine does is it does exactly what I just said for an index seek. It seeks down to find the first matching record for our particular predicate. It takes that record and it gives it back to the query processor. The query processor does its thing because the interface between the query processor and the storage engine is one record at a time. The query processor says to the storage engine, hey, please get me the next record. Now, the storage engine doesn't usually have to go back all the way up to the root page and say, okay, let's find the next record plus one, conceptually. It keeps, if it knows it's doing a multi-record seek or scan, it keeps what's called a cookie on this page here. And as long as this page doesn't change, the next record on the page must be the next record to be considered for the search predicates that we're acting on. So let's say that our cookie doesn't get invalidated. So the storage engine just said, okay, get the next record. Gives it back to the query processor, and so on until it gets to the last record down here, gives it back to the QP, and the QP says, okay, get me the next record. The storage engine says, oh, no more records. So it goes up to the page header, and the page header has some information about what's the next page. So it has to have that information because there's no guarantee that the page that has the next set of key values on it is the next physically contiguous page in the data file. It could be anywhere in the file group where this index exists. So there's a thing called a page ID. And so the thread that's doing this seek or scan goes and calls into the buffer pool and says, hey, get me this page, please, based on the page ID. If the page is already in memory, the thread immediately comes back and carries on doing the scan of this page. If the page is not in memory, then the thread has to issue a physical read of this page. It has to stop. It's going to wait for a page IO latch underscore share wait, and it's going to take a millisecond or a few milliseconds, depending on your IO subsystem, to read that page into memory. We don't like that. We like the pages to be in memory because we don't like physical reads because they're very slow. Anyway, at some point, the thread will get this page in memory and it will scan through here, no more records, follow the page ID, scan through here, no more records, follow the page ID, give them back to the query processor one at a time. And then it gets to the end down here, and we find a record that doesn't match the search predicate. And so the storage engine says to the QP, no more records. And that's the end of our seek or scan. Okay. Now you'll notice that what I said previously was, when we get to the end of this page and the thread tries to read this page, if the page is already in memory, excellent, we carry on going. If the page isn't in memory, it has to issue a physical read and it has to stop and wait for that page to be read into memory. That slows down our scan. Okay? The more pages we're having to stop and read from disk, the slower the scan is going to run, because every one of those page reads might be a millisecond or multiple milliseconds to read. If you have a very, very fast SSD, you might have a few tenths of a millisecond. That's still a delay, because a few tenths of a millisecond waiting for a page read is thousands of times slower than a processor. So the processor does have to, or the thread does have to stop and wait. So we still don't like having to do page reads, even on the fastest IO subsystem. So how does SQL Server try to avoid having to do these single page reads? It uses a mechanism called Readahead. The idea is, as the thread is scanning, imagine this is a many tens of thousands or millions of pages. As it's scanning through this leaf level, it wants to make sure that these pages are there in memory in the buffer pool when the scanning thread says, hey, get me this page. In that case, this thread just continues. So how does it do that? As the thread is scanning across here, there's also a scan happening up here, where what's going on is, because these pages, the way an index works is these pages at the level above the leaf level have a list of all the pages in key order. And so the page IDs of those pages can be used to drive pre-reading these pages into memory. Okay? That is called reading ahead of the scan point, or to shorten it, read ahead. And the read ahead is what helps make scans or multi-record seeks more efficient by making sure that there are no physical IOs that have to be done by the thread that's doing the actual scan. And again, doesn't matter what speed your hardware is, if the IO subsystem has to do multiple single page reads, it's going to be slower than a read ahead. Okay? It might only be a few milliseconds slower, but for some people, those few milliseconds makes a difference between a system running properly and a system running slowly. So the idea behind read ahead is to make sure that the threads doing the scan don't have to wait for IOs. And of course, it's more efficient to do larger IOs. Consider having to read in 8 pages. Is it more efficient to do one trip down and up the IO stack that returns 64K, or is it more efficient to do 8 trips down and up the IO stack, each reading 8K? Obviously, it's more efficient to do the larger read. So the more read ahead reads we can do, the better it is. Now, the read-ahead reads vary in size, up to a 4 megabyte read in 2016 and onwards. So that's reading in 4 megabytes worth of contiguous pages. Now, the better contiguity you've got, in other words, going back here, the more pages you've got where the next logical page is also the next physical page, the better the read-ahead IOs you can do. And so being able to make larger read-ahead IOs means your pages have to be in order. They have to be in physical order that's the same as the key order. And this physical order that's the same as the key order is what's commonly known as fragmentation. It's one facet of fragmentation. And I'll go into that in a little bit more depth. First of all, Shane, have we got any questions so far?
We do have a question, actually. Someone's asking how the read-aheads are issued. Is there another thread scanning the level above the leaf and issuing the IOs, or is it something different?
To be To simplify it, you can think of it as there's a scanning object, if you will, and the thread or threads that are part of the scanning object will either do a quick read ahead IO, or we'll be doing the actual scan at the bottom. That's the easiest way to think of it.
Perfect, and that's it.
Okay, cool. So logical fragmentation. This is the words to define what I just said, where the next logical page is not the next physically contiguous page. Okay, and this could happen for a variety of different reasons, usually because of an operation called a page split that we're going to get to. And this is what most people think about when they say fragmentation. They're thinking about logical fragmentation that can slow down read ahead and hence slow down multi-row seeks or reads. Okay. But there is, as it says right down in the bottom in red, there is so much more to fragmentation than that. Right? Don't just think of index fragmentation affects scan performance. Now here you'll see it does not affect pages that are already in cache. Okay, so if your index is memory resident, then it doesn't matter what kind of fragmentation you've got because the index is already in memory. And so any one of the threads that's doing the scan that asks for a page, the page is always going to be there. And also, if you have small indexes that maybe aren't memory resident, the effect of having not so good read ahead is not going to be so noticeable most of the time. Okay, I'm not going to say never because there's no never in SQL Server. And by smaller indexes, I mean 1,000 pages, maybe up to 5,000 pages, depending on which version of SQL Server you're on and how fast your hardware is. And you might have seen some guidance. You'll see guidance in books online saying if your index is less than 1,000 pages, don't do anything about fragmentation because it's probably not worth it. And this was guidance that I came out with back in the SQL Server 2000 days, where I'd be lunchtime in my Microsoft Office, doing the old Usenet news groups, which is the precursor to the forums that we have now. And people will be posting on the forums every so often saying, hey, I've just rebuilt my indexes and I still have 45.5% fragmentation. What do I do? And I'd reply back saying, how many pages does your index have? And they'd say 17. And I'm like, dude, it doesn't matter. Okay, take a chill pill. So for small indexes, you don't have to worry about fragmentation so much. You might have a pathological case where you have a small index where the fact that this fragmentation does cause you a problem. But as a generalization, that's usually not an issue. So this is logical fragmentation. Okay, next logical page is not next physical page. Slows down read ahead, slows down scans. Okay. Now the other kind of fragmentation that most people don't consider is wasted space. So if you have fragmentation, it's generally because of an operation called a page split, and we're going to talk about page splits in a little bit. And the idea behind a page split is to create free space for an operation to occur. So if you have lots of page splits happening, you've got lots of free space potentially. And if you have pages where there's a bunch of free space, every page is 8K, and it'll take up 8K in the buffer pool and 8K on the disk, even if it only has 50% of the space actually used. So the more pages you've got with lower than optimal amounts of space used, okay, or I should say lower page density, because that's the technical term for it, lower page density, then you're taking up more space on disk. You're having to do more reads to read the same amount of data into memory because that data is now split over multiple pages. And the worst thing is you're using up more of your memory. Your memory is basically your most precious resource on your server. So the more fragmentation you've got, likely the lower the average page density is on those fragmented pages, and the more space it's using up in the buffer pool. And that overall, if you've got lots of low page density pages and you can't fit your workload into your buffer pool, that means you're driving more page reads. The more page reads you're doing, the more threads you've got waiting for pages to be read into memory. And again, even if it's just a millisecond or so, that's still thousands of times slower than the CPU. And with a very heavy workload, that will manifest itself as a slowdown in performance. Okay? So even if you don't do scans, this kind of fragmentation can still affect your performance by stopping all your workload being in memory. So the generalization that you hear of, oh, if you have SSDs, and then you don't have to care about fragmentation because read ahead doesn't matter so much, isn't true, because that's not taken into account the wasted space. Okay? Hardware doesn't stop the wasted space. Okay? And you can see the amount of page density using the DMV, index physical stats, that we're going to talk about and I'll show you. So here's an example. This is the results of a survey that I did a few years ago, where I put out some code using the DMV sys.dm/os buffer descriptors. And you can go to that bit.ly link down there and you can get the code and you can see a bit more information about the survey results. And this was information back from 900 random servers across the world. And what the code did was it figured out how much memory the buffer pool was using to store pages, not how much memory is on the server, how much memory was in use storing pages in memory. And out of that set of pages, what percentage of all the space in those pages was empty? Right? Now, I would draw a line at 30% and say basically anything below there on average for a person's buffer pool, probably fine, based on their use of index fill factors that we'll talk about a bit later on. But here's some outliers. So this is a logarithmic scale of the amount of memory in use storing pages. So this is maybe, what, 200 gig, 256 gig, something like that. So this is 256 gig of space being used up, but 62% of it is empty space, right? Now that's not a very good use of that memory because it's storing a bunch of empty space. And that could be a server that's suffering from having to do a lot of reads. And if they took account of that fragmentation and did something about it, they'd be able to fit more of their workload into memory and not have to take so many reads. And so things would go faster. Here's another couple of examples over here. So on our logarithmic scale, this is what, 9 gigabytes, 10 gigabytes. So these might be small VMs, but look at this, more than 90% of that buffer pool space is empty. Again, that's not a very good use of that memory. So if you don't take anything at all away from this session, what I'd like you to do, if you've never looked at fragmentation on your servers, is go and run this code. It's pretty simple to run. The bigger your server is, the more memory, the longer it's going to take to run. It's not causing you a performance problem when you run it. You can think of it as doing conceptually a no-lock scan of the contents of the buffer pool. Right? It's not slowing anything down. But this will tell you for your buffer pool what percentage of the in-use memory is empty space. And you might be surprised or shocked on some of your servers to realize that you've got a big performance issue that you didn't realize, and this could be what's causing it. So before we get into page splits, any last questions on fragmentation and the kinds of fragmentation, Shane?
Yeah, a couple actually. So we've got one asking, well, just trying to confirm, isn't the free space in the pages what we insert on purpose by using FILLFACTOR?
Yes, so the free space that you insert on purpose using a fill factor is why I say if you have basically 30%, then anything below that is probably just because of use of fill factor. When we get to fill factor, you'll see that you're making a trade-off of allowing there to be some space so that you're not having to do page splits. Okay, so absolutely right. You are proactively allowing there to be free space rather than having the system create 50% free space. Okay.
Perfect. We got a quick one here asking if your code works in Azure DB. I think that code there.
It should work on Azure's SQL database. I don't see any reason why not, unless that DMV is specifically prohibited. I haven't run it on Azure SQL database. To be sure. So what can I do? I can try it afterwards. If that person wants to send me an email, I can try it. Or if they want to try it and let me know, we can do that. But I just don't know if that DMV is allowed or not. If it is allowed, it's not going to show you, well, it'll probably show you the fake master and stuff like that because you're running it essentially as a container inside another instance. So I don't know. I would hope it would work, but I haven't tried it.
Okay. Yeah, we got a few coming in, but I'll just give you one more. We'll say, do you still recommend to reorganize and rebuild indexes even if your storage subsystem is flash storage?
Yes.
Okay.
Yes. Because if you have a bunch of wasted space, then you've got to think about the effect of this wasted space and having more pages. Okay? If you have wasted space, you're taking up more space on disk on your expensive flash storage, and you're taking up more space in the buffer pool, which could be driving more reads. Right? So let me go back and say, not necessarily yes, but you should evaluate whether the fact that you've got this empty space there is causing you a performance issue. And if you can get rid of it and that gives you a performance boost, then yes, you still have to do the index maintenance. And that's what it all comes down to. And this is why I don't like some of the advice that I see where people say, you don't have to care anymore. Well, that's not true. You have to do, just like without flash storage, you have to do an evaluation to say, if I remove fragmentation for index X, does that help my performance? And then that's a no-brainer. That means that you should every so often remove fragmentation for index X to help your performance. If index X doesn't have anything to do with your performance, don't touch the fragmentation on it. So it's not a sledgehammer. And we'll get to that a little bit more when I talk about how I would go about doing index maintenance.
Lovely. I'll let you go back to it, but we did have someone come back saying it does work on Azure DB.
Ah, fantastic. So it does work on Azure DB. Perfect. Okay, cool. Thank you, whoever that was. All right, I'll carry on. Thanks, Shane. So how does fragmentation happen? And by fragmentation, we're talking about the logical fragmentation, and we're talking about the page density. And most of the time, fragmentation is happening because of an operation called a page split. And a page split occurs, if you think about how an index works, when you insert a record, there is a defined index key. So the new record has a defined point in the index where it must be inserted. Right? You have no choice, or I should say the storage engine has no choice. Now, you might have created a clustered index with some ever-increasing key, in which case you are essentially controlling where the new record goes. But if you have a random key, essentially, then the key value defines where the record's going to go. And if that means that the record's going to go into a page that is already full, SQL Server has no choice. It must insert the record there. So that means it has to create free space. The same thing happens if an existing index is updated. Let's say you've got a variable length column like a varchar 100, and you're storing the value Paul, and you update it to store the value Paul Randal works at SQL Skills. That means there's a whole bunch of extra bytes have to be added to that record. If there isn't enough space on the page for that record to get longer, SQL Server has no choice. That record has to live there because of the key. And so the page has to have free space put on it. And that is done by an operation called a page split. And a page split generally splits the page in half. And then the new record is inserted, or a record is grown. So anything that makes a record longer could cause a page split. One of the things that you might not realize is that if you start using snapshot isolation, either read committed snapshot isolation or just snapshot isolation, anytime a record is updated, then there's a pre-change version of that record pushed into the version store in TempDB. There is also a 14-byte tag added on the end of the record with a timestamp for when the record was last changed and a pointer to the pre-change version of the record in the version store. That 14-byte tag makes the record longer. If there isn't enough space in the index in the page for that, then the page has to split. So you might have an index where you didn't have page split problems before you turned on snapshot isolation, and maybe you're only updating integer values, and so the records don't change size. But now you turn on snapshot isolation, the records start to grow by 14 bytes, and so you start to get page splits and potentially have a performance slowdown because of that fragmentation. Another thing that does this is if you have a readable secondary on an availability group. Everything on the readable secondary is converted under the covers to snapshot isolation. So the space on the secondary replica for the 14-byte version tag has to exist on the primary replica as well. So as soon as you turn on a readable secondary in your AG environment, any updates that happen on the primary replica are going to start to have empty 14-byte spaces added so that those 14 bytes can be used on the replica. What does that empty 14 bytes do? It can start to cause page splits. So readable secondaries can start to cause fragmentation issues on your primary replica where you didn't have it before. Okay. What do you have to do about that? Evaluate whether that causes you a performance problem. And if it does, start to use fill factors and potentially do periodic index maintenance, as we're going to talk about. So a page split, imagine this is a little microcosm of an index here. So we've got a page P, and I'll call that the parent page. We have this parent page here at a higher level in the index than the leaf level. We've got 3 pages at the leaf level, A, B, and C. So let's say that these pages are all full, and somebody comes along and does an insert, and the key value is such that the record is going to go onto page B. There's no space, so SQL Server has to do a page split. So it allocates another page. We'll call this page B1. Now, what do you think? If this index exists, what do you think the odds are of page B1, the newly allocated page, being able to be the next physical page in the data file after page B, probably around 0. Okay? So page B1 gets created somewhere in the file group where this index resides. Okay? Now, physically, it's who knows where. Logically, it has to be in between pages B and C. Okay? So page B's page header that was pointing at C as the next page needs to change to say it's now pointing at B1 and vice versa. Page C that was saying page B is the previous, is the previous page, is the previous page, now has to change to say it's page B1. So not only has this page split allocated this page B1, it's also had to change the 2 page headers of B and C. Now it takes half the records, generally, from page B, moves them to page B1 under the covers. It's very clever code that does this. It actually, if there's any locks on any of those records, it actually migrates the locks to be on page B1. So any in-flight transactions that are changing rows on page B aren't interrupted. Okay, just the rows move under the covers. And this is all logged, of course. And then because page B1 is down at the leaf level, then page P has to have an entry in it to allow navigation down to page B1. So we also have to change page P. Now, all of this stuff that changed here, all has to be fully logged, no matter which recovery model you're in. And it is committed by a special thing called a system transaction. It's irrevocably committed, no matter, even if your insert rolls back, the page split stays. Now, all of this stuff is fully logged, which means there's a bunch of extra log records generated. And this is expensive. So an insert that might generate just 1 log record suddenly turns into a whole bunch of extra log, maybe thousands of extra bytes of transaction log that's being generated. And there's nothing you can do with your fast SSDs that fixes this, that prevents this. Okay, page splits are still going to happen no matter what your hardware is. So you're still going to have to, if you want to prevent these, to reduce the amount of logging, use a fill factor. Okay, and then periodically do index maintenance to reset the amount of free space in the pages. Otherwise, you're generating all this extra transaction log that has to be backed up and restored and scanned by the log reader agent job for replication and replayed on your mirrors, replayed on your availability groups, and so on and so on and so on. That is a performance hit. Whether it actually affects your workload or not, you're going to have to do some analysis of that, but you can't just ignore it because you have fast hardware. Now, how do you track page splits actually occurring? It's unfortunate because what I've just described to you is what I call a nasty page split. Right? There are also good page splits in air quotes. Imagine you have an append-only insert pattern like an int identity column or a big int identity column as your cluster key. Then what you're doing is at the end of your index, you're filling up the page with rows, and you it then allocates another page and fills up the page with rows, allocates another page, and so on. That's not fragmentation, as we've just been talking about. However, the storage engine classes the operation of allocate another page at the right-hand side of an index and start filling it up as a page split. Okay, that's what I call a good page split. Now, unfortunately, all of the documented methods of tracking page splits do not differentiate between good and nasty page splits. Right? There's a page splits per second perf_mon counter in the access methods, doesn't differentiate. There's a leaf underscore count column in the index operational stats DMV, doesn't differentiate. Even the page split extended event doesn't differentiate. It tries to, but there are some cases where it does not tell you that it was a nasty page split when it was. The only way you can tell for sure, unfortunately, is you can look in 2012 onwards with an extended event session for a transaction underscore log event, and you can see a special log record that is only ever generated when a nasty page split happens, and it's called LOP underscore delete underscore split. Right? So you can look at that using an extended event session, and depending on the amount of login activity, that might have a small effect on your system. If you want to look for that in real time, a slightly better way of doing it is you can use the transaction log, or you can actually look in a log backup, and you can scan the log itself using the undocumented fn underscore db log or fn underscore dump underscore db log table value functions for that same log record, LOP delete split. And the blog post that I've got there shows you how to do it looking in the log or log backup. And it also links to a blog post of Jonathan's that talks about how to do it with extended events. So any questions?
Oh yeah, but none from that kind of unique module. They're all kind of going back to your previous question asking.
All right, so let's hold those till the end then.
Cool.
Okay. All right, so let's do a quick demo. So I'm going to show you how expensive page splits can be. A very simple demo. And this code will run on all versions back to 2005. Everything I'm showing you will work on all versions 2005 and onwards, unless I specifically tell you. So I'm creating this little database here called page split test. And my scenario I'm going to create is I'm going to create a table with roughly 1,000 byte rows and then a clustered index on the integer column. And I'm going to create enough space for one record to be inserted without causing a page split. And we're going to look and see how much transaction log is generated. The second record we insert will cause a page split. And we're going to see the disparity between the no split versus split in the amount of transaction log that's generated. Now, depending on which version of SQL Server you're running on, I'm running this on 2014 SP2 on Windows 7. Depending on which version you're running on, you'll see slightly different numbers because the log records change size in every version of SQL Server. The further back in time you go from 2014, the smaller the numbers are going to be, a little bit smaller. And if you're running on 2016 or 2017, the numbers are going to be a little bit larger. So I'm going to start an explicit transaction and do one insert, and this is not going to cause a page split. Then I can use this nice DMV, DMTran database transactions, scoped down to my database to see how much transaction log has been generated by that insert. So 1,256 bytes. So I'll commit that, and then I'll do another insert. This one's going to cause a page split, and we'll see how much transaction log was generated. 7,580 bytes. So that's an extra 6,000 odd bytes of transaction log because we had to do a page split. So now let's go to a roughly 100 byte row table, medium rows. The same clustered index on it. And space for one record and not enough space for two records. We do our insert and we see without a page split, 356 bytes. So the 1,000 byte record, it was maybe what, 4 or 5 times more transaction log to do the page split. So for the 100 byte record, 356 bytes versus 6,772. So what's that? 17, 18 times more transaction log for that insert because we had to do a page split. So now let's drop down to roughly 10 byte rows. Very roughly. And here I'm going to do what's called a skewed page split. I'm going to make it so the storage engine decides not to do a 50-50 split, but actually decides to move the majority of the stuff off of the page. It's called a skewed page split. Now in this case, my insert is doing, without a page split, 268 bytes versus 11,172 bytes. So that's what, 40, 45 times more transaction log because of a page split, albeit a skewed page split. If we'd done a 50-50 page split there, it would have been about 6,000, 7,000 bytes, which would have been about 20 times more transaction log. So, and that's the end of the demo. Very, very simple, just showing you that when a page split occurs, there's an awful lot more transaction log that has to be generated because half of an 8K page has to be moved to a new page, plus all of the kind of linkage fix-ups that are done. And your fast hardware doesn't stop that happening. Okay, fill factors and periodic index maintenance to reset the amount of fill factor is what stops that happening, if that is a performance problem for your environment. Okay. So I'm going to crack on here because I don't want to run over my time slot too much. So what causes fragmentation? Well, if you consider fragmentation being the logical fragmentation and also the low page density, random inserts. So anytime you've got a GUID as the first key in, say, a clustered index, that causes fragmentation. Right? And that can even affect fragmentation of non-unique, non-clustered indexes as well, as I'm going to show you in the next demo. Anything that changes the size of a record, right, can cause fragmentation. If your fill factor is in use, but you've configured it incorrectly, okay, like maybe you've made it too small, so you're not leaving enough free space, that can lead to fragmentation. Now, the clustered index, as I say there in the second bullet point, is probably the only one that you can design such that the key matches your insert pattern. Because as soon as you have non-clustered indexes on different keys, by definition, the inserts are going to be random for those, and you're going to start to see fragmentation, which may or may not be causing you a performance problem, but you can't just put blinkers on and ignore it. Something that can cause wasted free space is very wide schemas. Let's say you have a 5,000 byte fixed size row. How many of those can you get on an 8K page? One. So that's 3,000 bytes lost per page. Okay, lots of wasted space in the buffer pool. You might want to redesign, or you might want to think about that when you're doing your design, because most of the time you can't redesign. You might want to think about that when you're designing, and think about the data density of pages. The more space you can use on your pages, right, the better the data density and the fewer pages you're going to be having to read as part of your regular workload. Remember, we don't like physical reads. Even deletes can cause fragmentation, because if you have an append-only insert pattern like I've described, but you go back and you delete records in earlier pages in your index, those deletes, the space that's freed up from those deletes will never be reused by new records by definition, because the index keys are appending at the right-hand side of the index. So you might find that over time on a large index or large table, your page density is gradually going lower and lower and lower. And at some point you might hit a tipping point where now you can't store all of your workload in memory. And if you were to do some kind of single time index maintenance that would squish all that free space together and get rid of it, you'd be able to have a better data density and more of your workload in memory. So any questions on causes of fragmentation, Shane, before we go on? And I'm having a quick drink of water as I do this because I've got a bit of a cough, unfortunately.
Yeah, no worries. Take your time. The causes of fragmentation, not so much. We do have questions on fragmentation as well, but it seems to go on fill factor. But one did go in just there saying, are included columns in an index a cause of fragmentation?
Included columns. So included columns are non-key columns that are at the leaf level only of a non-clustered index. And they're only going to be, well, let's see. Yes, they could be. They could be, but it's not a reason to not use them. They could be something that lends itself to fragmentation, because if the index row that you're inserting into your non-clustered index is larger, then the odds of there being enough free space on a page for that random insert go down a little bit. Now, let's say that you've set your fill factor to 70, leaving 30%. We're just about to talk about that. The bigger the non-clustered index records are, the fewer of them can fit in the amount of free space that you leave. So you might run out of your free space faster and have to do more frequent index maintenance on that index if that is causing you a performance problem. Okay. The other thing to think about is the more columns you have in your non-clustered index, and the more of your table columns that you update as part of your workload, that means that the non-clustered index column that's included might also have to update. If that means it gets longer, that could cause a problem. Or if you have snapshot isolation turned on in one of its forms, that could also cause there to be that 14-byte tag added onto the index record. And so that might cause a page split. However, I would not say don't use non-clustered index records because it might affect fragmentation. I would say, regardless of whether you've got included columns or not, analyze the fragmentation in your indexes, identify those that have high fragmentation, and if getting rid of that fragmentation gives you a performance boost, then you need to do something about that fragmentation. Doesn't matter what the schema is, doesn't matter what the index is. If you can make your performance better by addressing fragmentation or preventing page splits, then you should do so. Okay?
Yep, no, that's perfect for me. I'm going to ask this question because it's come up in a few different ways, and we'll just to get out of the picture. Mm-hmm. What is the best fill factor to start out with?
We are just about to talk about that. So I'm not going to answer that just yet. Is that a nice segue for me to get back into the slides?
You know it is, and I can leave the others to later.
Okay, perfect. So fill factor that I've mentioned a few times now, and that question was a great lead into this. The idea behind fill factor is you recognize that you have fragmentation occurring from page splits, and you want to be able to do something to try to prevent page splits from happening so frequently. So remember, page splits are where a page does not have enough free space for the operation required, whether an insert or an update of a record. You can proactively leave free space, right? And that's called setting a fill factor on the index. And you can only set a fill factor when an index is created or an index is rebuilt. Okay? The fill factor only applies when the index is being created or rebuilt. Okay? The fill factor does not apply during regular inserts, updates, or deletes. Okay? It would make no sense at all for you to define, let's say, leave 30% free space, and it always left 30% free space. It never used it. So the fill factor is a directive for how much free space to leave when the index is created or rebuilt. After that, when you've got regular inserts, updates, and deletes happening, that amount of free space will be used up. And the trick you've got is, what's the right fill factor to use, and how often do you have to do an index rebuild or reorganize to reset that amount of free space to the fill factor? So we're going to talk about what's the best fill factor to use. You can specify it per index. You can specify it for the entire instance. I do not recommend specifying it for the entire instance, because the odds are you have some indexes, maybe large clustered indexes, where you do not have fragmentation issues at all. If you specify an instance-wide fill factor, then any index rebuild of that maybe big clustered index will set the fill factor for that index, and you're going to waste a bunch of space that's never going to be reused. You could set the fill factor for an instance, but then for those indexes that don't need a fill factor, you have to go and specifically say, use the fill factor of 0 or 100. It's the same thing. Right? It's much better in my mind to only identify those indexes that require a fill factor and set it just for those indexes. Now, if you're a SharePoint admin, you will see that it sets the index, the SP configure option for fill factor to 80. That says leave 20% free space. That is because the SharePoint team recognizes that most SharePoint instances do not have a DBA looking after them. And so it just uses that SP configure option as a sledgehammer. I don't want you to do that, though. I'd like you to be a bit more finessed about it. So what is the fill factor number to use? Well, the number that you specify is how full you want the pages to be. So if you specify a fill factor of 70, that means when the index is rebuilt, it leaves 30% free space. Right? Now, for an index that doesn't have fragmentation issues, leaving it at 0 or 100 is the same thing, is good. And for OLTP, the best value to use is, there is no best value to use. Okay? It depends. And it depends on how prevalent page splits are for that particular index. Okay? And what kind of performance problem having page splits and fragmentation on that index has on your workload. So what I generally tell people is pick a number, put it in production, and monitor the fragmentation and your performance. Right? And then maybe tweak the fill factor for that index up or down, or tweak the periodicity of your index maintenance. And the number that I generally advise people to pick as a good starting point is 70. And you'll see that all over the place around the world. People just putting 70 in production and walking away. And that might be completely fine for you. Right? But again, I'd like you to monitor and maybe change that. Right? So 70 is a good first guess if that index has big fragmentation issues. Okay? Don't just go set 70 all over the place. So how can we find fragmentation? Well, let's see if there's any questions on fill factor, because there were so many. Are there any that I didn't answer yet?
Sorry, Paul, I didn't realize I was muted there. No, the only two questions we have is one asking if fill factors apply to the page level.
It's applied to the leaf level of the indexes only. If you want to push it up to the non-leaf level, you use with pad_index. Very rare to use that, and I generally don't see it as a problem. So leaf level only during an index rebuild, reorganize, or index creation.
And the second question is more of an observation. Someone did a test where they randomized the first column of the index, and it seemed that that was the only one causing fragmentation. Is that correct, or is there different scenarios where that wouldn't be right?
Do they mean that, I'm guessing what they mean is they had a multi-column index and the fragmentation was caused by the higher order column being random, not the lower order column. And that would be correct if the higher order column, if the index key is unique. If the leading column is non-unique, so you could have a large run of, let's say you could have 1 million records where the first key column is the same, then having random second column in your multi-column index would then start to cause you fragmentation.
Okay.
If that makes sense.
I'll ask him, but I think you're right. And
Yep.
That's it so far.
Okay, cool, I'll carry on. So detecting fragmentation. The best way to detect fragmentation is to use the DMV that detects fragmentation. Okay, there's some other methods you can use, but this is the easiest. Now, this DMV, it's not actually a DMV. Everybody uses DMV as a kind of catch-all. We should really be saying DMO for dynamic management objects. And DMOs are comprised of true DMVs, dynamic management views, and DMFs, dynamic management functions. A DMV is one where the metrics that are reported to you have already been calculated by SQL Server, and the DMV just pulls them out of memory and reports them. A DMF, a function, is where the metrics are not already calculated, and so the function has to go and do a bunch of work. This one is a function, and it's the most expensive function because it's going to go and have to read a bunch of pages from disk. So one of the things that I sometimes say is if you have index maintenance where you've identified maybe hundreds or possibly even thousands of indexes in your large database where you care about the fragmentation, you're going to run the DMV on those indexes, and that in itself might cause a read workload which could affect your performance. So one thing you can do is you can take a backup of your database, restore it somewhere else, and then run the DMV workload on the restored copy, because the restored copy of the database has exactly the same fragmentation inside the data files as the backup, as the database when it was backed up. So you could run the DMV workload over on a different server and then pull the results back to your prod server and use that to drive whether you're going to do any index rebuilds or reorganizes. There's 3 different ways that you can run the DMV. There's the limited mode, which is the default, the detailed mode, which reads all the pages at the leaf level, so that's the slowest. And then if you have an extremely large table and you want to get an idea of some of the detailed information, you can run sampled, which just reads every 100th page. It's not a truly valid, statistically valid sample, but sometimes it can be good enough. So the limited mode uses the same trick that Readahead does. It doesn't actually read the leaf level of the index. And the idea is that if there might be a factor of 10 to 100 times fewer or more, or less maybe, but generally a large number of times fewer pages at this level, okay, what I call the parent level, as there are at the leaf level. So if you just care about what's the fragmentation, what's the logical fragmentation, and how many pages are there, you can get it from the limited mode, because the limited mode uses the fact that this level here has a list of all the page IDs in key order. So it can calculate the logical fragmentation and it can calculate the number of pages at the leaf level. So if those are the 2 metrics that you care about, you can just use the limited mode. If you want to look at the average page density, you're going to have to use the detailed mode or the sampled mode. So there's all kinds of things that the DMV tells you, and it's really simple to interpret the results in terms of fragmentation. Logical fragmentation, so the average fragmentation in percent. If that is an issue for your indexes, then you want that to be low. Okay? The average page space used in percent. If that is an issue for your indexes, you want that to be as high as possible, as close as possible to your fill factor value that you've chosen for that. And then you look at the number of pages. Those are the 3 things you have to care about. Okay? You don't have to look at fragments or fragment size. It mentioned these in books online because when I redesigned the DMV instead of show-config, we figured let's invent some new way of thinking about fragmentation to make it simple. And I think we failed dismally because this is just as complicated as anything else. So you can just look at logical fragmentation, page density, number of pages. So let's have a little look at using the DMV. I'm going to hold questions now till the end, Shane, because we're at our hour point and I don't want to run too far over before doing Q&A. People that just want to see the session can then drop off if they don't want to stay for the Q&A.
That's fine with me.
Okay, cool. So here's a script that I've already run. I ran it already because it takes 35 seconds. I didn't want to waste time waiting for it. And what it does is it creates a database called GUID test and then creates 2 tables with almost exactly the same schema. One called bad key table, which has a clustered index on C1, which is a random GUID, and one called better key table, which has a clustered index on C1, and this is a non-random GUID. It's called a sequential GUID. And then there's a non-clustered index on column C2 in both cases, which in both cases is a datetime column. And then I insert 250,000 rows into each of them. Okay, so it's a contrived test where I know I'm going to be creating fragmentation. So I'm just going to show you how you can look at fragmentation. Now, I could just show you the DMV, but just looking at the DMV is kind of boring. Look, there's fragmentation. So instead, what I'm going to do is I'm going to run the 3 different methods of using the DMV, and I'm going to use extended events to track and see how many IOs were done for each of them. So this little bit of code here is just turning on XP command shell so I can go and issue a delete out on my file system. And then I'm creating this event session, which whenever a SQL statement completes, is going to grab what I did, right? And then that will also have the number of IOs, how long it took, and so on. And this will run all the way back to 2008. I'm using the old names and conventions for using extended events, but this will work all the way back to 2008. So I go ahead and set up my event session, start my event session up, and then I'll run the 3 different ways of doing the DMV, and then I will stop my event session. Okay. So very quickly looking at the output from the DMV, we have a database ID, object ID, index ID. I wanted to have it say object name and index name, but I lost that battle. So you're going to have to do some kind of cross-apply with sys.indexes, something like that, to get the names. You can't do a join because this is a table valued function. Partition number, you can see it says partition number. SQL Server considers everything to be partitioned, even if you're not using table or index partitioning. It tells us the index type. This is the detailed mode. It tells us the index type. It tells us whether we're looking at data, whether we're looking at row overflow, or whether we're looking at lob data. How deep the index is, the number of index levels, the fragmentation to like 10 decimal places, and then this fragment count, average fragment size that I generally say ignore. How many pages there are, average page space used in percent, and none of this stuff we care about for fragmentation. Okay. Now for the middle one is the sampled mode. This is the limited mode. We get 1 row for each leaf level. Okay, we don't get the other levels. So we get the average fragmentation in percent, we get the page count, but we do not get the page density. Because it's not reading the leaf level, we don't get the page density. But oftentimes having the fragmentation is enough to know that we've got a problem, because fragmentation, again, generally from page split. So if you've got a high fragmentation, you've probably got a lower page density. And that's an inference that is generally a simple one to make. So we're looking at fragmentation and we're looking at the number of pages. But how expensive were those? So this, if you're running on 2012 or onwards, this is the code that you use to get the information out of the extended events. If you're running 2008 or 2008 R2, you use this piece of code, okay, because it's all stored as XML. And the XML changed a little bit in 2012. So here we can see that we have, when we did it, we have the duration. Okay, so this is the, and I actually ran that twice. So this is why we've got 2 result sets. Let's look at the first one. The duration in milliseconds, the number of logical reads that we did. Okay. Very few physical reads because those indexes are already in memory already because I just built them. So we can see this is detailed, sampled, limited. So the amount of reads that are being done by the DMV are far fewer in the limited case than in the detailed case. And you scale this up to a table that has millions of pages, and that becomes a big difference. And again, in terms of runtime as well. So this is especially important if you're running the index physical stats on your production system. And the fact that you've got this extra CPU, this extra IO happening could cause a performance issue while you're running this. This is where you might want to offload it to your other system. So this is proving to you that the detailed mode is more expensive than the sampled mode. But let's have a look at the actual fragmentation now. So this is a bit of code that's just taking the DMV, cross-applying it with sys.indexes. I'm doing a detailed mode scan, and I'm prettifying the output and only looking at a few of the columns. So we can see here that our bad key table, almost 100% fragmentation, low page density. 20,000 odd pages, the same number of rows in our better key table clustered index, less than 1% fragmentation, almost 100% full, and far fewer number of pages. Again, scale that up to millions and millions of pages, and there's a big difference there. But look at this. Our non-clustered index on our date time column with the bad cluster key is also fragmented. Okay, so this is a non-clustered index on a date time. It is a non-unique non-clustered index, and that's because my laptop can insert thousands and thousands of records every 3.3 milliseconds, which is the minimum time period that a date time column can resolve. And so that means, and this is a perfect example of where the leading key is the same. And so the second order key, this is getting back to that question that was just asked, this is proof that my answer was correct. The second key in the key column becomes the insert point decider. In a non-clustered index, I've got my date time column as the key, but because it's non-unique, the cluster key is added on the end of the key as part of the key. Right? And that's what provides the uniqueness of the index key for the non-clustered index. Because even though you define a non-unique key, under the covers, it must be unique. Okay? And because the cluster key is by definition unique, whether you set it to be or not, it also could have something under the covers that helps. Adding that in as the second order key makes the non-clustered index key unique. So the fact that I've got thousands and thousands of all the same date time value, and then a random GUID as my cluster key means that we get random inserts into the big range of all the same date time value, and we start to get fragmentation happening in our non-clustered indexes as well. A question I often get asked is, if you use something like a date time 2, would that fragmentation go away a bit? Yes. And if I just use a date column, would the fragmentation get worse? Yes. It might be essentially the same fragmentation level as the cluster index key. So the smaller the range of non-unique values, the less likely your secondary key that's random is going to cause you a performance issue because of page splits on your non-clustered indexes. So I'm going to leave that fragmentation there. We're going to talk about removing fragmentation, and I'll come back and I'll remove the fragmentation. Unfortunately, it's hard to do really, really cool demos around fragmentation. So it is what it is. So correcting fragmentation. Two realistic choices you've got: rebuild the index or reorganize the index. Okay. You could do create index with drop existing equals on, which is essentially an index rebuild. I wouldn't do that if you just want to rebuild and not change anything, because you have to specify the entire create index statement. I would just do an alter index rebuild. You could, of course, choose not to remove fragmentation. If the index isn't being used for scans, so logical fragmentation isn't hurting you, if the page density isn't causing you a problem in the buffer pool or on disk, and the number of page splits isn't slowing down anything to do with the transaction log, then you could maybe choose not to do anything about fragmentation. But I would not say, oh, I've got SSDs, I don't care about fragmentation. That is not correct. You do have to do some analysis. But on the other side of that, I wouldn't just rebuild everything every day. That's probably a complete overkill. However, if you know that you've got some fragmentation issues and you know that there is some performance benefit from rebuilding them, and you are just an involuntary DBA, maybe you're not a DBA at all, okay, you might just configure a maintenance job that rebuilds everything every day, especially if you have a window where the extra load for that isn't a problem, and so on. If you have a synchronous mirror or a synchronous availability group, you might not be able to do an index rebuild, because that can cause a whole bunch of transaction log to be generated and could slow down your mirroring or AG environment. That gets better in 2016, where they've got better with the amount of log stream compression between your primary and secondary AGs. You might have to use an index reorganize and do what I call staggered index maintenance, where you do a little bit of reorganizing every day. Go to Google or Bing and search for Paul Randal staggered index maintenance, and you'll see some stuff that I've written online about that. So a rebuild, I've got a slide on rebuild, a slide on reorganize, and then I've got a kind of, here's what you compare and contrast between them. Both a rebuild and a reorganize, you don't have to know anything about the schema at all. Just you have to know the table name, the index name. With a rebuild, you can control how far it goes in terms of parallelism. A reorganize is always single-threaded. The algorithm that I wrote doesn't lend itself to parallelism. Okay. An index rebuild is going to rebuild your index column statistics with the equivalent of a full scan. Okay? Or if it's a partitioned index, it'll be a sampled scan. An index reorganize does not touch your statistics at all. So you might have to do some statistics maintenance as well if you're using a reorganize. A rebuild and a reorganize can do single partition operations, or they can just work on all partitions. And you can do an online index rebuild of a single partition from 2014 onwards. If you have lob columns, okay, in your table, then your clustered index cannot be online index rebuilt before 2012. Okay. If you have text and text or image in your table definition, your clustered index cannot be online index rebuilt ever. Okay. In 2017, there's a cool feature where you can stop an online index rebuild. Okay. When you kick it off, you say you want it to be resumable, and you can pause it, and then it will pick up and carry on when you restart. Okay. This is quite a cool way of being able to have a kind of varying index maintenance window. A rebuild, if you go into the bulk logged recovery model, can be what's called minimally logged. It cuts down the amount of log that's generated. A reorganize is always fully logged. However, a rebuild will build you a brand new index no matter what. A reorganize only takes care of fragmentation that exists, so it might be more efficient in terms of the amount of log that's generated. And with a rebuild, you can do a sort in TempDB, which means the intermediate sort runs as part of the index build for an offline index rebuild are put into TempDB and logged in TempDB, okay, which can mean that there's less transaction log generated, which is a cool thing for AGs or mirrors. Right? And in fact, in 2014 onwards, those sort runs might not be persisted on disk until they actually have to be because of memory limitations, which can speed up the sort part of the rebuild as well. Now, a rebuild, as I said, builds you a new index. So it's kind of an all or nothing thing. If you interrupt it before it's done, you get nothing. An index reorganize can be interrupted at any time. And this is getting into some of the reasons that I wrote index defrag in the first place for SQL Server 2000 as an interruptible online alternative to DBCC DB reindex, which was the rebuild of the time, which was all or nothing and only offline. Also, the new index has to be built before the old one can be dropped. So you need a bunch of extra free space. Whereas with the reorganize, you just need one 8K page. That's all the free space that you want. So it's very space efficient as well. In terms of locking, if you're doing an offline index rebuild, the table is completely locked. No reads, no writes. Doesn't matter what kind of index you're rebuilding. For an online index rebuild, there are points at which locks are held. Okay? And I think I've got a slide in here that talks about that. For a reorganize, right, it's always online. It only requires a table intent exclusive lock. Okay? And I've already mentioned a whole bunch of this. You can stop it. It doesn't roll stuff back. There's progress reporting. You can make it do compacting your off-row lob storage. Depending on which build of which version you're on, they broke it. Okay? And they also fixed it. So that KB article tells you which builds are fixed. Okay? So for an index that has very little fragmentation, it's more efficient to do a reorganize. For an index that has lots of fragmentation, it's probably better off doing a rebuild because the reorganize might take longer. Okay. What have I not said? I've said everything that's on there. Okay. Now, one interesting thing, something that I haven't mentioned yet about fragmentation, which is the more pages there are in your index, that could affect the query plan that's chosen by the query optimizer. And so you might find that removing fragmentation allows the storage engine to do a more efficient plan. Okay. You might also find that removing fragmentation allows the query optimizer to do a plan that you might think is less efficient. Right? So you need to be careful if you're removing fragmentation because cached query plans might change or compiled query plans might change if there is a drastic change in the number of pages. So be wary of that. Right? So the comparison points you've got between a rebuild and a reorganize: how much space does it take? How much transaction log is generated? How fast is it going to be based on the amount of fragmentation? Do you require it to be online or not? And remember that online index operations aren't fully online. Do you need it to be interruptible or resumable or not? And do you want progress reporting or not? And this is going to help you make a choice between a rebuild and a reorganize. Now you'll see in books online numbers around when to choose what. And these were numbers that I made up when I was at Microsoft, just like the 1,000 pages guidance. And this is because people need some guidance on when to do what around fragmentation. And so I worked with customers, did lots of experimentation, talked to the customer advisory team at the time, which is now the Tiger team, and come up with numbers. And the original numbers I came up were 10% and 30%, and they've changed those in books online now to be 5% and 30%. The idea is if you have very little fragmentation, you generally don't have to do anything about the fragmentation. If you have a reasonable amount of fragmentation, less than 30%, and you want to do something about it, you're better off doing a reorganize. If you have a heavy amount of fragmentation and you want to do something about it, do a rebuild. Okay? And as it says down the bottom there, your mileage may and will vary. Okay? There's no hard and fast, here's what you must do. These are just guidelines. So here's the method that I'll use, and I've done this a few times. If you desperately want me to write some code for you that's going to do index maintenance, I'm going to tell you no, go use Ola Hallengren's code, because Ola Hallengren has fantastic code that does index maintenance, backup, statistics, and consistency checks, and it's completely free. And even if you don't want to use his code, go and download his code and just rip it off, because that's what he's written it for. It's complete freeware. So if you desperately want me to do it for you, though, here's what I will do. I will analyze your workload and see, for all the indexes you have that have fragmentation, which of those, when fragmentation is removed or prevented by a fill factor, make your workload go faster. And if the make your workload go faster is enough that you care about it, that becomes one of the indexes that we care about for index maintenance. And I'll put that into a table. I call it the driver table. For the DMV, index physical stats, I will only run the DMV on those indexes that we care about, because by definition, the other ones we don't care about. So why waste the CPU and IO running the DMV on those indexes? For each of those indexes, there's a threshold to determine whether to rebuild, reorganize, or do nothing. Okay? And then it keeps track of what the maintenance decided to do, so you can debug it in future. And then an optional thing that I do is I'll keep a counter of the number of times in a row that a particular index had to be rebuilt. And if it reaches a number, and I usually say 5, if 5 times in a row when index maintenance is run, an index had to be rebuilt, I can drop the fill factor by, say, 5% to some predefined minimum. Right? So that's the very simple method. And it's all predicated on, is an index getting fragmented? And by preventing or removing that, do you help performance? Okay? Doesn't matter what your hardware is. Can you get better performance by addressing index fragmentation? If the answer is yes, and performance is important to you, you should address index fragmentation. If the answer is no, or you don't care about your performance, don't do any index fragmentation or any index maintenance. Okay? It's that simple. But there is no, if you have fast hardware, you can ignore it. Okay? Because you can't, as I hope I've demonstrated. So a quick slide on online index operations, and then we'll remove fragmentation and see how well a rebuild versus a reorganize does on the various indexes. So this is online index operations. Okay, now, I said there is still a point of locking. We, because I was on the SQL team at the time, called them online index operations because almost online index operations is not a very good marketing term. However, they're only almost online. So we want to do an index rebuild. First thing that has to happen is a share table lock has to be held. And that's going to be blocked behind anything that's doing an update on the index, and that's going to block other things wanting to do an update on the index. When that S lock is held, it creates an empty index to be rebuilt into. It recompiles query plans that touch that index so that any updates to the index also update the new index. And under the covers, it kicks off a versioning scan, okay, using the versioning mechanism of the old index. It actually uses a different version store from the regular version store. The different version store only exists while there are online index operations happening. And then it drops the S lock to an IS lock. And that shouldn't block anything except somebody wanting to take a table exclusive lock or somebody wanting to take a schema modification lock for some reason. So the version scan happens under the covers. At the end of the version scan, we should have 2 indexes, one with less fragmentation and the old one. Then it has to take a schema modification lock. We call this a super exclusive lock. It is not compatible with anything. So there is a point where there could be blocking here. Now I've said blocking. You can, on 2014 onwards, say wait with low priority, where you can say, I want my S lock and my schema modification lock to wait with low priority. I want other people to be able to jump over me. And at the end of a certain number of seconds, either do nothing, which is kind of pointless, or kill me, the index rebuild, or kill everybody else. Okay, well, they're queries. Okay. And that allows you to work around the whole blocking problem, right? So once the schema mod lock is held, then it's going to drop the old index. So it gets rid of the old index, turns off the version scan, recompiles the query plans, and then we've done an online index operation. So that's how those work under the covers. Almost online, as you can see, but you can work around that a little bit on 2014. So final demo, we're going to get rid of some of that fragmentation. I warn you, it's not very exciting demo. So here's the fragmentation that we've got. Okay. So if we go into my GUID test database, what can we do? We can do an online index operation. We can online rebuild our clustered index. Now, this is not going to work before 2012 if you're trying it on your systems, because in my table, I snuck in there a 1 byte in row varchar max column. That is a lob column. On 2008 R2 and before, we'll get an error saying you can't do an online index operation. But I'm on 2014, so it works. So what did we have before? We had 99% fragmentation here. So if we go ahead and execute again, that's going to show the same stuff. We're down to 0.15%. Right? And we've got our fill factor that we set to 30% there. What about our non-clustered index? 22% fragmentation. Let's try doing an index reorganize. Now, an index reorganize is going to get you down to low single digits fragmentation because it's reorganizing in the space that's already allocated to the index. It's not going to get down as far as a rebuild into contiguous free space would be able to do. So we got down from 22% down to 2%. Right? Not bad. Unfortunately, with a reorganize, you can't set the fill factor. Right? So if we want to set a fill factor, we're going to have to do a rebuild. So we do a rebuild with a fill factor of 70. And we'll see if it got the fragmentation any better. So we were at 2%, 98, and we got down a little bit better with the index rebuild, and we managed to set our fill factor to 70%. So very simple demo, just showing you the way of setting fill factor and reorganize versus rebuild, and explaining about the whole lob column thing on earlier versions of SQL Server. So a couple more slides, and then we'll stay for questions, as long as you guys want to ask me questions about fragmentation or anything else that I can answer. Can't guarantee to answer everything. One more thing to think about in terms of fragmentation, but also in terms of general performance. Are your indexes being used? Okay. There's all kinds of poor strategies around index maintenance, and I think Kendra's got a session coming up on indexing strategy, so I think you should watch that. One of the bad strategies might be, let's say we've got 100 columns in our table. Create a non-clustered index on just each one of those columns. So you have 100 non-clustered indexes. Most of those indexes will never be used, okay, because of selectivity issues, and hopefully she'll explain all that. Kimberly also has a course on indexing as well on Pluralsight. But yeah, there's all kinds of good information about indexes, but there's also bad information about indexes. And so you might have a whole bunch of non-clustered indexes that are not being used. If they're not being used, they still have to be real-time updated or maintained by the storage engine. So you've got inserts, updates, and deletes happening on your table. They also have to affect all of those non-clustered indexes. So that's a resource waste in and of itself. Those same indexes might be becoming fragmented. And if you're doing kind of sledgehammer index maintenance, where you're just saying anything that has more than a certain amount of fragmentation, even if it doesn't affect performance, just rebuild it every night. That's a bunch of work for those useless non-clustered indexes that you're doing. So you can look for a DMV, go Google or Bing for DMDB index usage stats, and you can use that DMV to tell whether you've got indexes that are not being used. Indexes that are not being used are candidates for being dropped. Don't just go drop them willy-nilly, because they might be enforcing a uniqueness constraint, even if they're not being used. But just check that you don't have unused indexes or duplicate indexes. That's another interesting thing. If you Google or Bing Kimberly Tripp duplicate indexes, you'll get her code that will find duplicate indexes for you. Duplicate indexes can be dropped because by their very definition, they are duplicates, and you only need one copy of each index. So to summarize around preventing fragmentation. Fragmentation does happen, and it is very expensive when it happens because of page splits and the extra logging. If you hear people saying that you don't have to care about fragmentation because you have fast hardware, they are wrong. You have to consider fragmentation. You can't just ignore it. It might not be a problem for you, but you have to determine whether that is the case. Because with fragmentation, you are going to have wasted space on your I/O subsystem. You are going to have wasted space in your buffer pool. There is going to be page splits happening. That generates a bunch of extra transaction log. That might be a problem for you, and none of that is solved by having SSDs or flash storage. If you find that you do have to care about fragmentation, setting appropriate fill factors is a great way to do it, and then rebuilding or reorganizing as necessary. If you're coming up with a new design, try to set your clustered indexes to avoid page splits, because these are generally the largest index that you need to remove fragmentation for. Some resources for you. I've blogged a bunch on fragmentation. I've got a 3-hour, I think it is, course that goes into a lot more depth around index fragmentation and a bunch more demos. Ola Hallengren's scripts. These are the gold standard in terms of free index maintenance. I always recommend those. And there's a very old white paper that talks about index fragmentation, and there's a link to it there. Unfortunately, there's no newer white paper that talks about that. They never wrote a new one. If you are an insomniac, there is a white paper that talks about how online index operations work in great detail. It's a great white paper, but it's very, very dry. So with that, we are done with my presentation. So Shane, let's open it up and do Q&A.
That's cool. We have quite a few Qs. I hope you have the
Okay.
answers. All right. One person would like to know, how can they do a reindex if they have a 24/7 environment and they don't want to impact production?
So if you have a 24/7 environment, I would look at using an index reorganize, because an index reorganize is going to generally have less of an impact on your system than an index rebuild. And of course, as I said, that's one of the reasons that I wrote index defrag in the first place, which became alter index reorganize. And you might also look at doing staggered index maintenance, where let's say even an index reorganize takes 3 hours to run. You might say, okay, I can afford maybe 20 minutes a day. Okay, where I take a bit of a perfit. So you start your index reorganize, and after 20 minutes, you kill it. The next day, you start it up again on that same table. Hopefully, there won't be in the earlier portion of the table a bunch of index fragmentation that it has to get. So it'll get very quickly back to where it was. You could do that. Another thing you can do is if you have tables with partitions on them, you can run index reorganize or rebuild on just a single partition. So maybe you've got a sales table with 2018 data going all the way back to, I don't know, 2015. The 2018 data is the only bit that's going to be fragmented. So only defrag the bit of data that's actually fragmented. Of course, if you have one monolithic sales table, you can't do that. But if you use partitioning in some way, you could just do targeted index maintenance. Okay? Partitioning is a great manageability feature, and one of the things it does allow is targeted index maintenance. But there's no magic answer. There's no way of removing fragmentation without removing fragmentation. But again, I would check to only do it for those indexes that are going to cause you a perf boost, going to give you a perf boost when you remove the fragmentation or prevent it.
Okay. We have a question regarding index rebuilds affecting transaction replication. If the publisher database is into bulk log mode first, would that help, or would that make any difference at all?
So if you're able to switch into bulk recovery model, and there's all kinds of why you might not be able to. If you're using a mirror or an AG, you can't. You have to stay in full. If you have 24/7 user transactions that you can't get back any other way apart from doing a restore, then you carefully consider whether you want to go into bulk logged, because there are some disaster scenarios where you might not be able to do a tail of the log backup if you've been in the bulk log recovery model and done a minimally logged operation. But if you're able to go into the bulk log recovery model, an index rebuild is going to generate fewer transaction log records, which means that there's less transaction log for the log reader agent job to have to scan. So that could help the performance of the log reader agent job, especially if your log file is on slower IO subsystem than kind of dedicated flash storage. Again, this is a case where you might want to use an index reorganize and judiciously choose, because an index reorganize is generally going to generate fewer log records than a full-scale index rebuild.
Okay. We have a person waiting a long time for this, so I will ask it. Is there any recommendations regarding FILLFACTOR for SharePoint databases that would be different from SQL Server databases?
Yes, you could do the same analysis for a SharePoint database that you do for a SQL Server database. Okay, you could do exactly the same analysis and pick different fill factors for certain indexes, because SharePoint has the SP configure option set to 80%, which leaves 20% free space everywhere. If an index in its metadata has a fill factor specified, all of the index rebuild and reorganize will use the index's fill factor over the SP configure option. So you might find, depending on how you use SharePoint, that some indexes could do with a more free space or maybe require less free space. And if you set it per index yourself, then the index maintenance jobs that SharePoint has, or if you're doing it yourself, will pick up the per index fill factor over the SP configure option. That's all I would do differently for SharePoint.
All right. We have a question regarding the unifier.
Okay.
And it is gone. Let me just find it again. Sorry. The question was, would there be any advantage to adding the primary key to the end of a non-clustered index in order to remove the unifier?
So no, you can't actually do that, because if your primary key is a cluster key, which is the only way it's going to have a unifier, so you've defined a non-unique primary key, and by default under the covers that's going to be a clustered index. SQL Server adds this hidden column called a unifier, which only exists in the row when you've got duplicate values for your cluster key or your primary key. The unifier becomes part of the cluster key under the covers. So if you then have non-unique, non-clustered indexes on the table, the entire cluster key is added to the end of the non-cluster key as a hidden unifier itself. So that means your non-clustered index, let's take the example that I had in my demo. Let's say I'd created a non-unique clustered index based on the GUID. My clustered index would be GUID, under the covers, GUID, comma, unifier, okay, conceptually. My non-clustered index, non-unique on the date time, would be under the covers, date time, comma, GUID, comma, unifier. And there is no way you can prevent that. The only way you can stop the non-clustered index having the unifier in it, in fact having the cluster key in it, is to define it to be unique. And then the cluster key, although it will be in the index row as essentially the bookmark that's used to look up other columns in the base table, it will not be part of the non-clustered index key. I hope that all made sense.
It did, but actually, hold on a second.
And the person that asked that, if it didn't make sense what I just said, by all means ask the question again or send me an email, paul@SQLskills, and I'll explain it in a bit more depth if you want.
Yeah, I think he came back and just asked if I'd ask it word for word. So I'm just going to do it quickly. For a non-clustered index, would there be an advantage to explicitly adding the primary key column in the last key position, simply to allow the index to be defined as unique and eliminate the need for a unifier?
Okay, if there is a unifier in the clustered index, that means your primary key is not unique. So what you say wouldn't be possible, because if you add a non-unique column as the last column in the index to try to unify it, that's not going to work, right? You only get the unifier in the clustered index if the cluster key is non-unique. So by adding it in the non-clustered index, that's not going to help the uniqueness of the non-clustered index, because what you've added is non-unique. So let's stop on that question. If the person still doesn't understand, please send me an email and we can go backwards and forwards in email. Okay.
Sure. Someone has asked about dbcc show config to get fragmentation on information. Is that still relevant or is that gone?
So under the covers from SQL Server 2005 onwards, the dbcc show config runs exactly the same code as alter index reorganize. Sorry, as index physical stats DMV. So show config has been deprecated. I would move over to using the DMV. Okay, but under the code, if you're still using the show config, you're running exactly the same code as the DMV does. There's no difference. There's a difference in how it's presented to you, but I would move to using the DMV.
Okay, there's a couple here that actually.
Hold on, Shane, but to answer the letter of the question, yes, the output you're getting from show config is still relevant, but you'd be better off running the DMV. because you'll get slightly different output.
I was just saying there's a couple here that I think are really good, but I'm just trying to get them through all the thank yous. So excuse me if I'm a bit slow. Okay, so using the availability group in SQL 2016 and using all those scripts, rebuilding in TempDB is faster than reorganizing, 10 to 20 times faster. This person would like to know why.
It entirely depends on how much fragmentation there is that the two commands are dealing with. Remember I said that a reorganize is going to be slower potentially than a rebuild if there's a large amount of fragmentation. So it's most likely something around that. If that is not the case, send me an email and we'll look at your index physical stats output and see what else could be going on.
Okay. In SQL Server 2016, we have duplicate indexes in the MSDB database. Can you delete them? It seems to be system indexes.
Interesting. Okay. If they are duplicates, if they're true duplicates, and you're not looking at SP help index, you have to run Kimberly's code, or you have to actually script the indexes out to check for included columns, because SP help index doesn't tell you the included columns. If they're true duplicates with the key order, the same included columns and so on, then by definition, one of them is not necessary if there's two of them. Whether you're able to drop them or not depends on whether there's just what tables they're on. You may not be able to do anything about that at all.
I was going to say, I think Kimberly updated that help index one lately, didn't she?
Yeah, it's like SP help index 4064 or something. I think it's like 24 or something. She's done quite a few revs of that. So.
Okay. Actually, the same person has another question, which is about how often should you fragment a heap?
I think they mean defrag a heap. So, heap, the issue you've got around fragmentation is very, very different. It's where, because there's no concept of an index, right? The problem you've got with a heap is what's called forwarded records, where if you have a record on a page in a heap, and the page is completely full, because you can't use FILLFACTOR on a heap, and you update the record to be longer, then the record will move to a new page. And in the original location, there'll be a little stub record left called a forwarding record. Now, non-clustered indexes are still going to point at the physical location of that original, record. And so the forwarded record problem is where you've got a query that's using the non-clustered index, does a bookmark lookup, comes across to the heap record location, and the little stub record says, aha, I'm not the real record. The real record's over there. And so there's another page read involved. And that can be a performance issue. If you're using heaps, can be a performance issue, not always. Remember, there's generalities, there's never an always. And so what you might need to do if that is causing you a performance issue is remove those. Now, there's two things you can do. You could periodically do an alter table rebuild on that heap. An alter table rebuild was added in 2008 to allow data compression to be enabled on a heap. The problem when you do the alter table rebuild is it builds you a new heap, changing all the record locations, and that means that all the non-clustered indexes on that table have to be rebuilt. Another thing you could do is create a clustered index. That will rebuild your non-clustered indexes once, but from then on, you've got a clustered index, which may or may not have fragmentation issues. Okay, so it might be better in terms of performance. It's not always the case where a clustered index is better than a heap. It depends. There's a few little niche cases where a heap could be better. But if you're finding you're getting lots and lots of forwarding records happening, then you might consider moving to a clustered index. However, if you're finding lots of forwarding records, that's because you're updating records. And so you might find that you get fragmentation issues on your on your clustered index because you're making records longer. But with a clustered index, you can provision a fill factor to try to avoid the page splits happening. So a clustered index might be better for you than repeatedly rebuilding a heap and causing all your non-clustered indexes to have to rebuild every time you do that. Again, there's no right answer to any of this. It's all a big it depends. Okay, but now you know what it all depends on in terms of fragmentation. There's no always rebuild or always don't rebuild or always use a clustered index, always use a heap. You have to think of the various pros and cons and decide what's right for your environment and your particular maintenance window and so on.
Yeah, that's fair enough. Like we're in the DB job or data platform job. It depends. We hear a lot.
Yep. The trick though is, and if you ever hear somebody say it depends, push them to explain what it depends on and why. Because it depends by itself is a really crappy answer. But it depends as the start of an answer is perfectly acceptable for me.
Okay. I've got two more if you want the time for them.
So I have as much time as you have.
Okay. This one has come in for AG in 2014. Would it be better to put the AG into async, do the index rebuild, then put the AG back to sync? Or would it be better to put the AG in async, do the index rebuild, then put the AG back to sync again? Actually, I just copied the question twice,
Yeah.
sorry.
How is my answer going to start, do you think? It depends, right? If the fact that you're doing an index rebuild with your AG causes you an AG performance issue, then you could potentially do async, do the rebuild to allow the queue of log records to build up, and then go back to synchronize to allow it to catch up. And this might be better. The only thing I would say as a downside to that is once you go into async mode in your AG, then you've got what's called a send queue building up on your primary. And if you have a disaster, then there's log records that haven't been sent across to your replica, and you might lose some data. If you're having performance issues on 2014 because of index rebuilds, I would suggest doing staggered index maintenance, where you're doing every night you're doing a little bit of index reorganize, and that is reducing the amount of log that's being sent, and you can control how long that runs for. So again, go Google or Bing, pull Randal staggered index maintenance, and have a look at that.
Okay, and the other one I saw was there's more coming in, and if they're like great, I will shout them out to you, but I don't want to keep you on too long. Can fragmentation affect the same way within temp tables?
Yes, there's nothing in temp tables or the structure of temp tables that prevents fragmentation occurring. If you have very large, long lifetime temp tables, that could be a performance issue for you. I haven't seen that be or I haven't heard of a client having a problem like that. This is the first time I've ever been asked this, but theoretically, there's nothing that would stop fragmentation happening. If you have a very, very large temp table that's living for a long time, I would ask you, why are you doing that? Why is your table not memory resident? I mean, you could have a perfectly good reason for that. No, I can't think of a reason why it wouldn't. Would I be all bent out of shape about that? Probably not. So it's kind of hard to say whether I'd really care about that, to be honest.
One of the attendees was asking if you specifically use the ascending keyword on one of the columns in the index, how would this affect fragmentation and page density?
So the ascending keyword is the default. It's implied unless you specify descending. So no difference. It's not so much your key value. Sorry, it's not how you define your key so much. Hold on a sec. Let me step back. It doesn't matter whether you're saying ascending or descending. It's what's your insert pattern. So if you have an ascending integer, okay, and you specify the integer value, then you have the potential for inserting randomly. If you have a key that's an integer and you say it's an identity, you cannot specify the value, or unless you say set identity off. You're generally not specifying the identity value, and then it's an append only. It's appending on the right-hand side. It's a monotonically increasing key value that's being auto-generated for you. So it's not so much the ascending, it's more, are you doing random inserts? Are you allowing random inserts? And you can very easily do a random inserts with an ascending key, because by definition, all keys are ascending unless you say otherwise. So the demo that you saw me do with the GUIDs, by default, that GUID key that I defined was ascending, right? Because I didn't specifically say descending. So just saying ascending doesn't stop fragmentation. It's your insert pattern you have to think about.
Yeah, no, that's perfect. That's fair enough. I will do one more, but then I do have to go, seeing as I've missed the last two trains. Let's see. Does index fragmentation exist in the underlying table fragments of a full text index?
Not in the way that we're talking about here. And it kind of depends on whether we're talking about 2005 or earlier, or whenever integrated full text was put in. because the structure of full text changed. And I can't remember whether it was 2005 or 2008. And in the earlier version, whatever that was, your full text catalog, you would have to, in air quotes, defrag every so often, because it would build your full text catalog, and there's more full text data came in, it would be appended in chunks on the end. And every so often you would have to kind of rebuild that to get all of the full text data in order. Now, integrated full text uses a kind of opaque B-tree structure that you can't see, where it takes care of that automatically. So the kind of fragmentation that we're talking about around rows and so on, you can't really do anything about. But the full text and the whole rebuilding of full text, I don't believe you have to do it anymore. I'm not a full text index expert, so I'm like this is a 90% certainty answer. This is not a 100% certainty answer.
That's fine. And like, just to let you know, I'm gonna try and stop now because I have to run, but I still have 19 questions on my screen to ask you. So yeah.
So anybody that didn't get their question asked, please, by all means, send me an email, Paul@SQL Skills. You're not putting me out in any way by sending your question in email. I'd like to help you all out for those of you that were on the call today. So just send me an email, and I'll go back and forth with you and help you out.
Yeah, I do want to double down on that, because Paul has stayed here an extra, I don't know how long, to answer your question. So if he's done that, he is more than able to answer your emails as well.
Absolutely. It's all about community and helping people out.
Yeah. I'm not sure if Steve is there, if he wants to finish up. Let me just check now. Doesn't seem to be, so I'll just finish up. Paul, thank you. I don't know what to say. This is probably one of the most informative webinars I've been on in a long time, actually.
Thank you so much. My pleasure.
Thank you for that.
Absolutely, my pleasure.
I will just finish up saying thank you, Paul. Thanks for everyone for attending. Next two webinars we have is with Hamish Watson down in our Down Under chapter, which will be on the 10th of April. And then we've got Thomas LeBlanc on the 17th of April, which will be on this chapter at the same time. Thank you, everyone. And please keep an eye out. We'll update you all when the video is available.
Thanks.
Thanks a lot. And I'll just stop.